Before we start this lesson on Lewis structures and the octet rule, let's review a bit. Atoms are composed of protons and neutrons that live in the nucleus, and electrons that orbit the nucleus in energy levels. The periodic table is an organized way of categorizing all the elements. Remember that the letter in each square of the periodic table is an abbreviation of the element. The number up above the letter is the atomic number and also the number of electrons. The number under the letter is the atomic mass. Atoms like to be stable. They go to great lengths to be stable and happy. Stability to an atom is a complete outer energy level. The outer energy level is full of the valence electrons. Valence electrons are the electrons in the highest occupied energy level of an atom. The number of valence electrons mostly determines the properties of an element. An octet is a set of 8. Think octopus, an animal with 8 legs. Octagon, a figure with 8 sides. And octomom, a woman who had 8 babies at one time. In chemistry, the octet rule says that atoms like to have full outer shells of only 8 electrons. Atoms will lose or gain valence electrons to make their outer shells full with 8 electrons, and they do this by bonding with other atoms. Those atoms can be the same element as when oxygen bonds with itself to form O2, or with different elements, such as water, H2O. The exceptions to the octet rule are hydrogen and helium, which are both happy with 2 electrons in their outer shells. A Lewis dot structure is a quick and easy diagram that shows the valence electrons in an element. In a Lewis structure, the nucleus of the element is represented by its symbol. The valence electrons are represented by dots placed around the symbol in pairs. This type of diagram helps to identify how an element may react in a chemical reaction. To make a Lewis dot structure, you first have to identify how many valence electrons an element has. The easiest way to do this is to look at the element's group number on the periodic table. The group is a column on the table. Group 1A has 1 valence electron. Group 2A has 2 valence electrons. Group 5A has 5 valence electrons. Helium in group 8A is the only exception. It has only 2 valence electrons. Once you know how many valence electrons there are, that's how many dots you put around the symbol. The dots go on all 4 sides of the letter symbol. Put a single dot on each side up to 4 electrons. Then pair them up if you have more. For example, fluorine, F, is in group 7A. Therefore, it has 7 valence electrons. It is written with a capital F with 7 dots around it. How about oxygen in group 6A? What do you think it looks like as a Lewis structure? That's right. A Lewis structure makes it easy to see when an element would want to bond with another element. By quickly looking at the dots around the symbol, you can see if the outer shell of that element is full. If it isn't full, you know it is going to want to chemically bond with another element. Look at fluorine again. You know that it isn't full because of that lone dot sitting right there. Fluorine is going to want to bond, possibly with another fluorine, so it can fill that empty spot right there. 2 elements that are bonded with shared electrons can be shown like this, or with a line between them to show that they have a chemical bond. Elements can form more than one bond between them, but that's a lesson for another time. So to review, a valence electron is an electron in the highest energy shell of an atom, and the octet rule says that atoms like to have full valence shells of 8 electrons. A Lewis dot diagram shows the valence electrons in an atom by representing them as dots arranged in pairs around the letter abbreviation for the element.